Egyptology, our field, is not just about papyri and hieroglyphs. Of course, you do need what we call philological competence, but you also need something else, and that is a certain familiarity with quantitative methods from outside Egyptology. In our case, in Crossing Boundaries, we have deep relations with informatics and artificial intelligence. In this sense, we are a truly transdisciplinary project that combines humanities, social sciences, and hard sciences.
By using double-sided printouts of the front and back of a papyrus, we reproduce them as one-to-one models. Like this, we can work with them in a way we could never do with an ancient object. Observing the different folds, breaks, and traces, we can investigate the folding techniques of the ancient scribes. This way, we can understand how an ancient Egyptian prepared a message for delivery or storage. This letter was probably still found as a tiny folded package when it was discovered by archaeologists. To write the letter, the scribe did not use a new papyrus sheet, but reused an old one, as can be seen on several traces of older ink. A reused manuscript is called a palimpsest.
Many of the papyri from the el-Medina are palimpsests and still show some traces of previous texts. The erased text can sometimes be made visible with the help of ultraviolet or near-infrared light filters. Since we cannot examine the originals at the moment due to the COVID-19 restrictions, we have to rely on working with high-resolution photographs. With the help of color enhancement software and manual tracings on the enhanced images, it is possible to create some preliminary drawings of the erased text. Once the access to the papyri is granted again, these drawings will be corrected after the examination of the originals.
We also study the use of computer science on the papyri. Did you know that a machine can learn to identify a papyrus fragment within a photograph and automatically cut it from the background? There are many interesting features for automatic analysis, like the layout, the individual handwriting, characteristic holes, the outline of a fragment, and even the fiber structure, to name just a few. Such features will help a machine to suggest which fragments might belong together. This will be used in the virtual light table we develop. Once you add a new fragment from the TPUB database, it will recommend other, potentially adjoining fragments. You can move them around and rotate them as you see fit. You can flip the fragments to look at their backs, or even flip the whole table. The results can be saved and printed to share them with other scholars.
We decided to create these videos and share them with you online to give you an idea of our work in home office during COVID-19 lockdown. We hope you enjoyed it. Take care and stay safe.